So this is the B3C3P3 higher past paper 5. Remember, you've always got this equations table in the front of your paper. Make sure you use it particularly in the physics section where quite a few of the marks are just choosing the right equation and then plugging your numbers in. But the first section is biology, so it says, look at the diagram of the heart. So you've got the vena cava there. You need to work out what X is, and that is the tricuspid valve. And you must spell that right. Next question. The vena cava is the main vein entering the right side of the heart. Veins contain valves and arteries don't. Explain why arteries do not need valves. And so your first mark is for saying what valves do, so they prevent backflow. And the second mark is saying why arteries don't do that. It's because the pressure is always high enough to prevent backflow or push blood forwards. Or you could say that pressure is higher in arteries than veins. So first, valves prevent backflow. And then second, pressure is always high enough in arteries to prevent backflow. Next question is a 6-mark question. Can you mark this yourself, please, using the mark scheme that's on the Google site? And then if you need to ask your teacher to check it for you, then by all means do that. This next question, look at the picture. It shows rice being planted in China. Rice belongs to the plant kingdom. Write down the name of one structure found in a plant cell that is not found in a bacterial cell. So you could have had chloroplast or vacuole for that 1 mark. Scientists have taken the genes that control beta-carotene production and placed them into rice. This rice is called golden rice. Give 2 reasons why genetic engineering is used in this process and not selective breeding. So 2 marks here. You could say that beta-carotene genes not found in the rice. You could say that genetic engineering is quicker. You could say that more control over making sure the desired characteristic is prevented in the offspring, present. You could say selective breeding can lead to reduction in genetic variation. So your first one there, beta-carotene genes not found in the rice. If you do selective breeding, you're not going to get this golden rice anyway because beta-carotene isn't there in the first place. And then genetic engineering is quicker. Those are probably your 2 that you want to be getting. Some people are opposed to golden rice because it may have unexpected harmful effects. Suggest how scientists could gather evidence to try to overcome this opposition. So the idea that you have to carry out controlled tests, or you could give examples of controlled testing, so testing humans to see if it makes them ill compared to a control group, or doing field trials to make sure it does not impact plants growing around. You can't put stuff like arguing or writing articles. It has to be the idea of carrying out controlled tests. Look at the diagram. It shows the cloning technique used to produce Dolly the sheep. Is Dolly a clone of sheep A or B? And explain your answer. So the first bit, it won't get you a mark just for saying which one it is. It is B, but that won't get you a mark. You've got to say this because the DNA or genes or chromosomes came from sheep B. So sheep A just provided the egg cell, but the nucleus came from sheep B, and that's where the DNA is. So it's sheep B, and the reason is because the DNA has come from sheep B. Since Dolly was born, many other animals have been cloned. Write down one possible use of cloning. So you could say mass-producing animals with desired characteristics. You could say producing animals that are genetically engineered to provide human products. You could say producing human embryos to supply stem cells for therapy. Any one of those. The diagram shows an animal cell. Write down the function of the mitochondria in this cell. So mitochondria do the respiration in the cell. So that's your mark there, just saying respiration. Then it is possible to work out the volume of the cell shown in the diagram. 1 millimetre on the diagram equals 1 micrometre in real life. Assuming it is a sphere, the volume is 4/3 pi r cubed, where r is the radius. So the cell volume equals 4/3 times 3.14 times 23 cubed equals 50,939 micrometres. Measure the radius of the nucleus and work out the volume of the nucleus using the same formula. So first you've got to use a ruler and measure the nucleus, and the nucleus is 8 millimetres. And then you do 8 times 8 times 8, that's 8 cubed, times 3.14 times 4/3, and that equals 2144. A group of scientists studied the effect of poisoning by the metal cadmium. They thought the metal caused the ratio volume of nucleus to the volume of cell to decrease. The ratio is normally between 0.1 and 0.05 for this type of cell. Has the cell been poisoned with cadmium? And explain your answer. So you've got to first calculate the ratio. So it's going to be 2144, that's your volume of the nucleus, divided by 5939, which is the volume of the cell, which is given to you. That equals 0.042. And then your answer is that it has been poisoned because the ratio is less than 0.05. Cara plays basketball for a club every day of the week. Cara finds a way to estimate her basal metabolic rate. She uses this formula. There it is. What effect does getting old have on BMR? Describe how you can tell from this formula. So you say getting older reduces the BMR, and you can tell this because the part of the formula involving age is given a negative value. So you take away the bit where you multiply by age. So that's going to take away from the BMR. So that's your answer. Cara gets injured and can't do any sport. Cara knows her total energy requirements depends on her BMR and her activity. Now that she is not exercising, does not want to eat too much and put on weight. Cara calculates her BMR as 6,000 kilojoules per day. The table gives a measure of an activity called an activity factor. There it is. The total energy Cara needs is found by multiplying her BMR by her activity factor. The energy Cara needs is released by respiration. During aerobic respiration, 6.6 kilojoules are reduced per gram of glucose. Calculate how much less glucose Cara needs to take in per day now she has stopped doing sport. This is a really tough question. So the first thing you got to do is the 6,000 times by 1.75, which is your very active factor, and that equals 10,500. Then you've got to do your 6,000 times 1.2, which is little or no exercise, which equals 7,200. Then you've got to take one away from the other to work out a difference. So 10,500 take away 7,200 equals 3,300. And then divide 3,300 by 6.6, which is how many kilojoules released per gram of glucose, which equals 500 grams. So your answer is 500 grams of glucose. Cara wants to calculate how much glucose she needs to play a game of basketball. Just why Cara should not use a figure of 6.6 kilojoules per gram of glucose to do this calculation. So there's one mark saying that some of the glucose will be used in anaerobic respiration, which does not produce as much energy, or some of the energy released will be from anaerobic respiration, so less energy is made per gram. So the idea that anaerobic respiration will be happening, and that releases less energy than aerobic respiration. So the next section is the Chemist Section. So Colin and Anne investigate the reaction between zinc lumps and hydrochloric acid. Hydrogen and a solution of zinc chloride are made. The diagram shows the apparatus they use. Look at the graph. It shows the results when 1 gram of zinc lumps reacts with 20 centimeters cubed of dilute hydrochloric acid. How long does it take for the reaction to stop? So it stops when the straight line, when the line starts to flatten off. So anything between 11 and 12 minutes will get you the mark. So between 11 and 12 minutes, or any value between those. And calculate the average rate of reaction during the first 4 minutes. Quote your answer to 3 significant figures. So in the first 4 minutes, you get 3.75, and the unit should be centimeters cubed per minute. So all you got to do is work out what volume was given off in 4 minutes and divide that by 4. And then how does the average rate of reaction of the first 4 minutes compare to the average rate of between 4 and 8 minutes? Show how you calculated your answer. So in the next 4 minutes, 12.5 centimeters cubed was made. So divide that by 4, and that gives you 3.125. So you can see that the rate is faster in the first 4 minutes than in the second 4 minutes. So so there's only one mark. You've got to show the calculation and say that the first 4 minutes was faster. This next question is a 6-mark question in the Chemist Section. Please can you mark it yourself, and then if you're unsure whether you've marked it correctly, just ask your teacher to check over it for you. Copper carbonate decomposes when heated. Copper oxide and carbon dioxide are made. There's an equation for it. Tim investigates this decomposition. Look at the apparatus he uses. Tim heats 1.24 grams of copper carbonate in the test tube. He predicts that he should make 0.8 grams of copper oxide. He actually makes 0.7. Calculates percentage yields. Remember, percentage yield is the actual yield over the maximum yield. There's always going to be the smaller number over the bigger number, so it's going to be 0.7 over 0.8. Then to turn to a percentage, you need to times by 100, and that should give you 87.5%. But if you put 88, if you round it up, that's also fine. If you only put this number, that would also get you both marks in this case. A factory manufactures copper oxide by heating copper carbonate. The carbon dioxide made as a waste product. Look at the table of relative formula masses. There they are. Calculate the atom economy for the manufacture of copper oxide. So remember your equation, which is on the previous page. Oh, not Ca, sorry, CuCO3 is the following. And remember, atom economy is the relative mass of the desired product divided by the relative mass of all the products, or you could use all the reactants. So it's going to be 120. It's going to be 80, which is your relative mass of the desired product, divided by 124, which is the relative mass of all the products added together, times by 100 because atom economy is a percentage, and you should get 64.51%. And then it is important for the factory to have a high percentage yield and a high atom economy. Explain why each of these is important. So 2 marks, 1 mark for explaining each one. So first mark, you say the high percentage yield is important to reduce the cost or increase efficiency by not wasting starting materials, or by reducing the need to recycle unreacted reactants. So I get your first mark. And then the second mark saying that high atom economy to make the process more sustainable or greener, or to reduce the processing of unwanted products. Next question. Diamond and graphite have different properties and different uses. Look at the table, it shows some information about the properties of diamond and graphite. So you've got the state at room temperature, appearance, melting point hardness, solubility and electrical conductivity. Mark decides to use graphite electrodes in electrolysis of sodium chloride solution. Use information table and your own knowledge to give reasons for his decision. So, first mark saying that graphite is a good electrical conductor. So there you are. Diamond doesn't conduct, so it has to conduct electricity. And the second mark saying that graphite has a high melting point, or it's solid or insoluble. Could say it's inert, so it will not dissolve, won't melt, or won't react during electrolysis. So those are your 2 marks. One for saying it's a good conductor, and the other one for saying any of those other ones. So the main one is that it's solid or insoluble, or it's inert, i.e. it doesn't react. Diamond and graphite both have very high melting points. Explain why. So if you're ever asked why something has a very high melting point, it's because they have strong bonds. And then the second mark you've got to say is that they take a lot of energy to break. So they have very strong bonds which take a lot of energy to break. Diamond does not conduct electricity. Explain why. Because they have no electrons that can move, or there's no free electrons, or there's no movement of free electrons. So it's the idea that the electrons can't move that's important. Claire prepares calcium nitrate. She reacts calcium hydroxide with nitric acid. Calculate the mass of calcium nitrate that can be made from 3.15 grams of pure nitric acid. This is a very tough question. So the first thing you've got to work out is the relative mass of the calcium, of the nitric acid, sorry. So you're going to do MR of the nitric acid, HNO3, and if you work it out, that's 63. And then you're going to divide the 3.15 by 63. And that equals 0.05. Then the ratio of nitric acid to calcium nitrate is 2 to 1. So for every 2 nitric acids, you make 1 calcium nitrate. So you're going to divide 0.05 by 2, which equals 0.025, and then times that by your MR of the calcium nitrate, which is 164. And so your answer is 4.1 grams. Now, if you got that, that is very, very impressive. I'd be really surprised if a question like that came up in your exam that was that difficult. Claire reacts double the amount of nitric acid in excess of calcium hydroxide. What effect will this have on the amount of calcium nitrate made? So that will also double if the amount of nitric acid is doubled. So the last section, the physics section, says this question is about motion and speed. Brian runs 100 metres. Look at the table showing the time he takes for 100 metres. Use the table to draw a distance time graph. So First thing you've got to do is have time on the x-axis and distance on the y-axis. So you've got to have it the right way around. So time on the x-axis and distance. And then sensible scales. So distance needs to go up to 100 and time up to 24. So you have 0, 5, 10, 15, 20, 25, and so on. And then distance 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And then plot your points. So you've got 0 and 0, and then 4 and 0. And then 40 and 12. Around there. 60 and 16. 80 and 20. And then 124. Something like that. Join the dots. So you get 1 mark for making sure your axis is the right way around, and the second mark for the rest, basically, making sure your points are plotted correctly and your scales are correct. Then use the graph to find Brian's speed between 8 seconds and 24 seconds. So that's 5 meters per second, if you work that out. And then Brian runs 100 meters again. This time he runs the race faster. He runs at steady speed. Draw the line for this race on the graph on the previous page. Label this line faster speed. So all you got to do is make sure that the straight line has a steeper gradient. So it's a steeper line, and that will get you that mark. Thomas runs a different race. Thomas runs a 200 meter race. His average speed for the race is 3.8 meters per second. Thomas's personal best time for 200 meters is 50 seconds. Calculate Thomas's time for the race and decide if he has beaten his personal best time. So you've got to work out the time. So remember, speed equals distance divided by time. So distance equals speed times time, and therefore time equals distance divided by speed. If you want, you can make a triangle for it. So speed equals distance over time, and then you can work out what you need to do. So distance divided by speed, so that equals 200 for the distance divided by 3.8 for the speed, and that equals 52.6, which means he hasn't beaten his PB because his PB is 50. So 1 mark for working out the time, 1 mark for saying that he hasn't beaten his personal best. Pat measures the speeds of 2 cars. The diagram shows the speeds of the cars. Calculate the relative velocity of car A and car B. So relative velocity is 1 take away the other, so it's going to be 15 take away 9. So the answer is 6 meters per second. If you just put 6, that's fine. Car A accelerates now, and after 4 seconds is travelling at the same speed as car B. Calculate the acceleration of car A. So you're going to do 15 take away 9. So it's the final velocity take away the initial velocity divided by the time it's taken, which is 4 seconds, which equals 6 divided by 4, which equals 1.5, and the units for this are meters per second squared. The driver of car B presses the brakes. The car stops. Look at the information about the car stopping. Explain what happens to thinking distance and the braking distance when the speed of the car triples. So thinking distance is directly proportional to the speed. So thinking distance will treble, and the braking distance has a squared relationship. So braking distance will multiply by 3 squared, which equals 9. So 1 mark for each of those. This question is about fuel consumption for different road vehicles. Fuel consumption figures depend on the road conditions, driving style and vehicle speed. Explain how one other factor affects fuel consumption figures. Use ideas about energy in your answer. So 2 marks here. So you could say that more mass requires a greater kinetic energy for a fixed speed, so more fuel needs to supply energy. So first mark saying more mass, second mark saying that more fuel is needed to supply the energy because you need a greater kinetic energy. Or you could say streamlining for a mark leads to less energy wasted against drag for the second mark, so less fuel is needed. Car manufacturers are required to publish environmental and running cost data about the cars they manufacture. This is to help car buyers choose which car to buy. So there's some data. It says Rowan and Anna want to buy a new car. They want a car which provides the best balance between economic and environmental impact. Rowan says we should buy car Z because this car has the lowest fuel consumption and is the quietest model. Anna realises that Rowan is wrong. Use the data in the table to explain why Rowan is wrong. Which car should Anna and Rowan choose? Give reasons for your choices. There were 3 marks. So the reason why Rowan is wrong is because he's got the fuel consumption back to front. So he's chosen Z because it has the lowest number, but actually the fuel consumption is in kilometres per litre, so the higher number is best. So there's your first mark, saying that more kilometres per litre is better. Then the next mark, you don't get a mark for choosing the car, you get the mark for the reasons. So the most economical or lowest economic impact is V, because it has the highest fuel consumption in kilometres per litre, or lowest cost for fuel. And then the lowest environmental impact is a choice between Z, which is the quietest, or V, which has the lowest carbon dioxide emissions. So that's also important when choosing a car. So therefore V is probably the best choice because it has the best fuel consumption and the lowest carbon dioxide emissions. The main fuels for road vehicles are petrol and diesel from crude oil. Describe how and why we may have to change the way vehicles are powered in the future. So, first marks were saying that petrol and diesel are finite sources of energy, or you could say they're non-renewable. And then the second mark was that for any one of these, you could say instead we could use biofueled vehicles, as they do not use fossil fuels, or we could say solar-powered vehicles, as they do not use fossil fuels, but they use a renewable energy source. And you can't just say electric cars, you've got to say what the source of the electricity would be, and that the source does not involve using fossil fuels, because most electricity is made by burning fossil fuels. So you've got to say a different source of that electricity. This next question is a 6-mark question, so please can you mark this yourself using the mark scheme on the Google site, and then ask your teacher if you're unsure whether you've marked it correctly. Brittany is a skydiver. Brittany jumps out of a plane, gravity acts on Brittany, Brittany's speed increases for several seconds, Brittany then reaches a terminal velocity or terminal speed. Explain why Brittany's speed changes, why she reaches terminal velocity as she falls. So, the first mark saying that speed changes because initially her weight is higher than the drag or air resistance, and then she reaches terminal velocity because then her weight equals the drag or air resistance. So those are your 2 marks, very specific. First, her speed changes because her weight is higher than the drag or air resistance, but you could say gravity for weight or friction for air resistance if you wanted to. The second mark, she reaches terminal velocity because her weight then equals the drag or air resistance. So that's the end of the paper. Please add up your marks, write them in your on your poster, and then move on to the next one.